Hey engineers and mechanical enthusiasts, welcome back to Engineering Insights. Today we're diving deep into one of the most revolutionary inventions in mechanical engineering history, gears. I'm your host, and let's jump right into this fascinating topic. Today's topic is the evolution of gears, from ancient times to modern engineering. Historical development. The earliest known gears date back to around 2800 BCE in China, though the first sophisticated mechanical gears were found in the Antikythera mechanism around 100 BCE. However, it was during the Industrial Revolution that gear technology truly transformed human civilization. Core types of gears. 1. Spur gears, the most common and simplest type. Used for parallel shaft applications, efficiency 98% to 99%. Typical lifespan 20 to 25 years with proper maintenance. Best for moderate speeds up to 3000 RPM. 2. Helical gears, features angled teeth. Smoother operation than spur gears, higher load capacity. Lifespan 15 to 20 years. Ideal for high-speed applications up to 100,000 RPM. 3. Bevel gears, used for intersecting shafts. Types include straight, spiral, and hypoid. Efficiency 95% to 98%. Lifespan 15 to 20 years. Crucial in differential systems. 4. Worm gears, high reduction ratios possible up to 100 to 1. Self-locking capability. Efficiency 70% to 90%. Lifespan 10 to 15 years. Excellent for heavy loads at low speeds. 5. Rack and pinion, converts rotary to linear motion. Common in steering systems. Efficiency 95% to 97%. Lifespan 10 to 15 years. Essential in precision applications. Maintenance and lubrication, critical maintenance factors, regular inspection every 3,000 operating hours, oil analysis every 6 months. Vibration monitoring, temperature monitoring. Alignment checks. B. Lubrication requirements. 1. Oil viscosity selection based on operating temperature, speed, load conditions. Environmental factors. 2. Common lubricants, synthetic oils, POW, POD. Mineral oils, grease for slow-speed applications. Engineering analysis. Key design considerations. 1. Lewis equation for tooth strength, sigma equals Ft, B times M times Y. Wear. Sigma equals bending stress, Ft equals tangential force, B equals face width, M equals module, Y equals Lewis form factor. 2. Contact stress Hertzian, sigma H equals square root Ft, pi times B times rho. Where E equals elastic modulus, rho equals radius of curvature. Modern applications. 1. Industrial, heavy machinery. Power plants, manufacturing equipment, mining equipment. 2. Automotive, transmission systems, differential, power steering. Clock mechanisms. 3. Aerospace, engine gearboxes. Flight control systems, landing gear mechanisms. B. Lifetime enhancement strategies. 1. Design phase, proper material selection. Adequate safety factors, optimal geometry. 2. Operation, maintain proper alignment. Monitor vibration levels, ensure proper lubrication. Regular maintenance schedule. 3. Environmental control, temperature regulation. Contamination prevention, moisture control. Note to engineers, this overview covers the fundamental aspects of gear technology. For specific applications, always consult relevant standards AGMA, ISO, DIN and perform detailed calculations considering your specific operating conditions. Remember that gear life can be significantly extended through proper design, maintenance, and operating practices. Thanks for watching. If you enjoyed this video, please don't forget to like, share, and subscribe to support the channel. Hit the bell icon so you never miss an update. Share this video with your friends, it really helps us grow. Keep me in your prayers. See you in the next one. Coming soon.